All right, so the last section of this notes is talking about the triangle inequality theorem. So essentially what the triangle inequality theorem is saying, the sum of any two sides of your triangle has to be bigger than the third side. So you can kind of look at that example there, but example one is asking, hey, can a triangle have the sides of 4, 7, and 8? So kind of I'm going to label this triangle up here with those sides, 4, 7, and 8. So in order for something to be a triangle, then if I add any of these two sides together, it has to be bigger than that third side. So for example, if I add 4 plus 7, is that bigger than 8? Well, yeah, because 11 is greater than 8. That is a true statement. Okay. Well, it now also is asking if I add the other two sides. So if I add the sides 4 and 8 together, is that bigger than the third side 7? Yeah, because 12 is greater than 7. Well, same thing with the last part. If I add those last two sides together, 7 plus 8, is that bigger than the third side 4? Yeah, it is. So the triangle inequality theorem is saying, hey, in order for something to be a triangle, three of these statements have to be true. So this first example, yes, the measurements 4, 7, and 8 could be possible measurements for a triangle. Like that exists. Okay. But example two here is now saying, hey, 4, 1, and 3. So if I label this guy 1, 3, and 4, could those be potential sides of a triangle? Well, if I check and I add my sides together, 4 plus 1 has to be bigger than my third side 3, which, yes, that works. Sorry. But if I check my other sides, well, if I add 1 plus 3 together, 4 is not bigger than 4. That's not a true statement. They're the same number, it can't be bigger than itself. So no. So since that isn't true, then 4, 1, and 3 cannot be a triangle. Okay. So number three kind of goes into the video that you kind of watched on the last page. So it's asking you to list the sides in order from the shortest to the longest side. So if I kind of draw this out, here's my picture. X, Y, and Z. Okay. It's saying that angle X has a measurement of 50 degrees. And then it's saying angle Y is 5y plus 10. Nope, it says 5x. So we're just going to restart. So here's my picture X, Y, Z. If I know this is 50, and I know this angle is 5x plus 10, and I know this angle is 5x, then going back to what I know about the sum of all my angles, if I add all three of those together, it has to equal 180 degrees. Okay. So if I solve, this ends up being 10x plus 60. So x has to be 12. So if I know the measurements are 50, well, angle y here has to then be 60 degree, 60 degree, no, 70 degrees when I plug it in. And then angle z has to be 60 degrees. So knowing that, it wants you to list the sides in order from shortest to longest. Well, if 50 degrees angle x is my smallest angle, then that means the side across from it, YZ, has to be the smallest side. Then my next side, well, 60 degrees is my medium angle. So that means a side across from it has to be my medium size, XY. And then my last one, 70 degrees was my biggest angle, which means my biggest side has to go across from it, which is XZ. So this would be the order of my angles from shortest to longest. Okay. Number four, you can kind of read through and kind of answer that on your own and then come back and check. So if you kind of look at the units there, Well, 1.7 is smaller than 70 and 150, but it's measured in meters. So 1.7 meters is actually 170 centimeters if you convert it, which means that angle R is the largest angle. Okay. All right. So kind of applying the triangle inequality theorem on page 29 here. So when the lengths of two sides of your triangle are known, the third side can be any length in a range of values. So if I know that two sides of my triangle have to be bigger than my third side, then I can figure out what the range of values for that third side could be. So it kind of wants to know, what could x be between in order for this to be a possible triangle? Well, if I add two of my sides together, so plate 3 plus 7, that has to be bigger than my third side, which is just x. Well, that just means that 10 has to be bigger than x. Okay, so I'm looking for anything that's smaller than 10. Okay, but if I check my other two inequalities, I can find what it has to be bigger than, right? So if I look here, well, if I do 3 plus x, my other two sides, it has to be greater than my third side, 7. That just means x has to be greater than 4. And then lastly, if I add my last two sides, 7 plus x has to be greater than 3. So that means x has to be bigger than -4. Okay. Well, if I think about this, okay, if I want any number bigger than -4, but it has to be bigger than +4, well, if I pick a number like 0, that doesn't satisfy all three of these inequalities because if I pick 0, 0 is not bigger than 4, right? So I essentially am kind of like ignoring this for right now because anything bigger than 4 is ultimately going to be bigger than -4, okay? But anything bigger than -4 isn't necessarily bigger than 4, right? So the range of values that x could be is in between 4 and 10, right? So if I think about that, possible side lengths for x, well, it can't be 4 because it's not greater than or 4 isn't less than or equal to x. So I could have a side length of 5, 6, 7, 8, or 9, right? So if I had any of these potential values for that last side, that could be a triangle. Anything other than these numbers wouldn't work, okay, because it doesn't satisfy our triangle inequality theorem. So go ahead and try number 1 and 2, and then you can come back and check your answer. Pause the video so that way you can try those. Okay, so there's kind of numbers 1 and 2 there, so you can kind of check your answer. If you're confused where that kind of came from, then make sure you ask on Thursday when I am back. Okay. So the last kind of example here is number 3. So it's kind of again determining the possible range values for x. This time though, it's just giving me 3 expressions for my sides, but same thing. I can kind of split this into three different inequalities. So that way I can check what my range of values would be. So if I add these two sides, x plus 5 plus 2x plus 22, that has to be bigger than my last side, 5x minus 7. So that is my first inequality with this triangle inequality theorem. So if I solve this, this would end up giving me 3x plus 27 which has to be bigger than 5x minus 7. So when I solve, this would be 2x and 34. So x has to be less than 17, right? So 17 is the biggest value that x could be, okay? Well, now I have to check my other two inequalities to see what my range of values would be. So if I add x plus 5x minus 7, it has to be bigger than 2x plus 22. So x plus 5 plus 5x minus 7, that has to be greater than 2x plus 22. Well, same thing, I could solve this. So 6x minus 2 has to be greater than 2x plus 22, which means that 4x has to be greater than 20. Oh, my pen stopped working. Okay, 24. So x has to be bigger than 6. Okay. And then lastly, I'm going to kind of go down here. So my last two sides that I can add would be 2x plus 22 plus 5x minus 7 has to be bigger than x plus 5. So that's my last inequality that I have to check. Okay, so basically I'm just checking all three of my inequalities to determine what my range of values would be. So this would be 7x plus 15, which has to be greater than x plus 5. So 6x has to be greater than negative 10. So x has to be bigger than negative 10 over 6 or negative 5 over 3, if I'm simplifying. Okay. So now I just have to compare all of them. So 17 is definitely the largest that it could be. I can't pick a x value that's bigger than 17, otherwise I'm going to get a side length that wouldn't work, right? And if something is bigger, greater than negative 5 over 3, that doesn't necessarily mean it's bigger than 6, okay? But I want x to be greater than 6. So 6 is going to be the smallest that my side could be, or my x could be. And then my biggest value would be 17. So my range of values have to be between 6 and 17, okay? So you can go through and kind of try number 4 as well, and then make sure you kind of get the right answer. Here is your answer so you can check after you solve it. But go ahead and work on your homework. It's pages 14 through 18 in your practice packet. All right. Let me know if you have questions.